This video is going to go over real numbers. It's going to be organizing into sets and subsets and showing how numbers are related to one another. On page 6 of your journal, I'm going to put down, this is page 6. There is a tree diagram that shows how the numbers are related to one another. At the top, it says real numbers. That's the whole system, kind of like a family tree. Real numbers break into two categories. The first category is rational numbers, and this is where most of our numbers fit that we use every day. Underneath rational numbers, there's a smaller group called integers. Under integers, there's even a smaller group called whole numbers. And then the smallest group of numbers we have are called counting numbers. That is in this pathway. If you go back up to the top, instead of going to the rational side, the other category we have is called irrational numbers. We don't use these numbers very often. They're most often used with square roots when a number is not a perfect square. It's going on forever, but we'll talk about the definitions in a minute. I want to put down the labels, the little symbols for these. Real numbers, the symbol is an R, and then put another stick on the back and connect it at the top. So it kind of looks like a bold letter R. Then for rational numbers, R is already taken. So this one, the letter that we're going to use is a Q, capital Q, and a line down the side. Irrational, the symbol we're going to use is a letter I with a double bar down the side. Integers, I has already been used. This is going to be a Z, and then it's going to have a double line down the center. Whole numbers is a W, and then it has an extra bold piece on one side. And then counting numbers are also known as natural numbers. That's going to be the letter N. And it also, like these, has a extra bar on the side. It's kind of like a bold letter N. So those are your symbols if you want to use initials instead of writing the whole words. Okay, the next 2 pages of your journal, this is page 7, and this is page 8. What we're going to do, if you happen to glue yours where they weren't side by side like this, it's okay. But if they are side by side, we're kind of just going to connect these two so it looks similar to the tree diagram from the page before. If yours are not looking at each other when you fully open your book, then that's okay. You don't have to do this. But at the top, remember, it was real numbers, and you don't have to stretch it across your book like that if you don't want to, but real numbers was at the top, and then it broke into the categories of rational numbers, irrational numbers. I'm going to put the symbols again one more time real quick on here. Rational number, that was the letter Q. Integer was the letter Z with a double bar. Whole number was a W with a double bar on the side. And the counting or the natural numbers, that was the letter N with a double bar on the side. And if I go back over here, irrational was the letter I. Whoa. With a double bar down the center. Okay. On this page, I'm going to look closely. I'm going to zoom in at the smallest circle where the natural numbers are. The thing to know about this one is this says it starts with 1. It's positive whole numbers only starting with 1. So, for example, in your journal, you could add, it would start with 1, and then you would continue 1, 2, 3, 4, so on and so on. Only positive whole numbers starting with 1 is the definition. That is the smallest group of numbers. When you fold that first flap down, the next circle is the definition for whole numbers. If you look really closely, the only difference is this one says it's starting with 0. We still only have positive whole numbers, but it does include 0 this time. So on my list up here, I would say 0, 1, 2, 3, 4, ... continues on like that. Fold down that flap, and then the next circle you get is integers. This one does have a slight difference. This one also includes negative whole numbers. But pay close attention. This says there are no decimals. There are also no proper fractions. Or no proper fractions, yes. Sometimes improper fractions can simplify to be a whole number, which is fine. But no proper fractions like 1/2 or 5 3/4 can fit, because then it wouldn't turn out to be a whole number. So for example, on my list, I would have ... -3, -2, -1, 0, 1, 2, 3, ... would be the list. Then the largest circle, the definition for this one, basically this is going to include almost all numbers that we deal with. It can be positive, it can be negative, we can have whole numbers, we can have fractions, we can have decimals, but here's the thing you need to pay attention to for this one. The decimals have to be a repeating decimal or a terminating decimal. Okay, there's another type of decimal that's going to go on the next page of your journal. So, for example, there's going to be a lot that I could put in here, but I could have -3, I could have 1/2, I could have 0.75, I could have square root of 16, because that turns into a whole number. I could have 5/4, because that's a terminating decimal. I can have -2 3/4. I can have just 7. It's pretty endless in this category. The other page of your journal, this should be page 8. This is the Lone Ranger. This is only irrational numbers. If you look at this one, the main thing to know is that most of the time it's going to, the simplified version is going to be a decimal. It's going to be ongoing, or it never repeats or ends up showing a pattern. So if you have a fraction, you want to turn it into a decimal. This is what this is saying. Simplify your fractions or square roots, and then see if it's going to be a decimal that's ongoing or a decimal that doesn't show some type of pattern. Most of the time, this is going to be square roots, but there are some fractions that when you simplify them, they do not show a pattern. So, for example, a super common thing that we say is irrational is pi, because that's an ongoing decimal that never ends and does not have a pattern. Something else is the square root of 2, the square root of 125. Also, I tested the fraction of 7/23, and that's also a decimal. When you divide it, that is not going to show a pattern. Okay, let's look at a couple examples, and I'm going to show you how to either use this circle diagram or this tree diagram to help you categorize and show the relationships between numbers. So, for example, if I have the number, let's say 3.25. Okay, all numbers are going to start up here with a real category. So that would be a real number. So I can put the letter R next to it. Once you get through with starting at the top, you're either going to branch off to the left or the right. It has to be one of these two. Okay, this is a terminating decimal because it's just stopping at 0.25. So this is a rational number. And rational, we said, was the letter Q. Now, after you go down further, integers, whole numbers, and natural or counting numbers, all three of these had to be a whole number. This includes a decimal, so it would not continue down this path. It's just a real number and a rational number. Next example, let's try -4. Okay, again, I'm going to start at the top. All the numbers that we're going to start with are real numbers. So I'm going to put the letter R. Then I'm going to either branch off to the left or the right. The number has to be one of these categories. Rational number, remember, was a whole number, a fraction, a decimal, as long as it was terminating or repeating. Irrational is a crazy number. We don't know what happens because there's no pattern. -4 is a whole number, so it's going to be rational, and that was the letter Q. Then after that, I'm going to go down and see, does it fit the integer category? It is a whole number, and integers could be positive or negative, so then yes, it's going to fit the integer category, and integers were letter Z. If you keep going down the chart, whole numbers and counting or natural numbers, these both had to be positive only. So then I would stop and say -4 fits these three categories. Okay, I'm going to try let's say square root of 16. Okay, square root of 16, I need to simplify that. That actually equals 4. So when I'm thinking through the question, I'm going to be thinking about the number 4 when I go down my chart. All numbers are going to start with real numbers because that's the top of the chart. It's either a rational number or an irrational. That doesn't have a decimal at all. I got rid of the square root because it's simplified down. Remember, the definition on your blue square said simplify it and see what it equals. So +4, that is a rational number. So that's a letter Q. When you look underneath your chart, integers are whole numbers. They could be positive or negative. So I'm going to put a Z. Then underneath that, whole numbers said you could have 0, 1, 2, 3, 4. So that fits. Counting or natural numbers said start at 1 and then 1, 2, 3, 4. So that fits that category as well. Whole numbers were a W and natural counting numbers were the letter N. So if a number is underneath, it fits all the categories above it, you would make sure to include all of those. Okay, I could check mark it like that. If I wanted to check the -4, -4 was an integer, and so I need to keep going up the path all the way till I get to real numbers. That way I know there should be 3 answers in the list. So if you want to use that for your visual check, you can on your chart. I'm going to do one more number. I'm going to give you an example. On the green page, we did square root of 2. Now, when you type that in your calculator to see what kind of decimal it is, square root of 2 is 1.41421, and it goes. Okay, this is an example of an irrational number. So everything above that also gets checked, which would include real numbers as well, but then that's it. So remember, everything is going to be a real number that we're dealing with, and then it's going to branch to either irrational or rational. And irrational was the letter I.